Hi everyone, thanks again for joining us. My name is Hunter Terry. I'm a coordinator at the Southeastern Center of Robotics Education. This is the third video in our three-part series on getting started with BEST Robotics. If you haven't already watched the first two videos, the link will be in the description. We'll be picking up right where we left off. I just showed y'all how to connect the cortex and the brain to the laptop in order to program it. We're going to jump right into programming it. Before we do actually pull up the software and start programming, I do want to go over a couple basics and do a quick refresher on how to plug things in case you are not watching this immediately after it. So if you remember, you're going to have this USB cable to your programming adapter, which looks like this. Your programming adapter is going to connect with that telephone wire looking programming cable to the back of your controller. And your controller should be connected to your Cortex via a USB cable. So that's that. I'm going to show you guys a couple different concepts using RobotC today. The first thing I want to show you is using your sensors. So when you have a couple of different sensors on your robot, there's different ways to program them. Obviously, it's not the most straightforward thing, but I do want to show you how to do it. And I have a couple examples there. The first example is using your limit switch to turn on and off a motor. And I'll show you a more specific way you can use a limit switch as sort of a safety stop to stop a motor when you don't want it to go any further. It's really useful for arms and claws and things like that. I'm also going to show you how to use the potentiometer to control different motors on your robot. Something you can do there is control the speed of your motors. So I'm going to show you how to do that. You can also use it as an encoder to tell you how far an arm is, but my program doesn't necessarily show that. I might try and throw something together for that. Next, I also want to show you how to use the controller. So there's two different schemes, general schemes. There's a lot of different variations, but generally there's two different schemes in the robotics world, specifically in competitions. You've got arcade, which maps the controls to a single stick, or you can do split. I'll show you a couple ideas of that. There is also tank drive, which maps it to separate like a tank, and I'll go into more details about that. But let's go ahead, switch over to our program, and let me show you how to get started in RobotC. So once you download RobotC from the link I showed you in that last video, in case you don't remember, it's aub.ie/robotc. That'll take you straight to a direct download. If that doesn't work for any reason, you can probably Google RobotC download and find it for free. It has been released as free software now. So yeah, if you have any trouble with that, always check out Google first. So here in the software, we actually, I've already made a couple programs. You'll see this one's titled controller, but I'm going to start with a new file. I always recommend you start with a new file if you're starting from scratch. So there's a couple different settings you need to change for BEST Robotics in RobotC. I'm going to show you a couple of those. The first thing I recommend is going to window and changing menu to super user. That's just going to show you all the options. Don't let that intimidate you. It's really not a ton of extra options that are going to scare you or anything, but that just makes sure you're getting all the options available. The next thing you're going to do is go to this robot tab. You want to change your platform type and make sure it's VEX 2.0 Cortex, and you want to make sure this natural language 2.0 is checked. That's just telling RobotC what language we're dealing with and what firmware we're dealing with on the robot. You can also update your firmware here. I'm not going to go into a ton of details, but what you want to do when you do this is plug your device directly into the laptop. So if I was going to update the Cortex, you want to plug the Cortex directly in with nothing in between, directly in the laptop. Hit that button and it's going to update the firmware. Same thing with the joystick. You want to plug the joystick directly via USB into the laptop and update it. Obviously, if you have, like an adapter, like I have a MacBook and have to use an adapter, that's fine. I just mean you don't want to be using the programming controller or anything like that outside whenever you're updating that firmware. So that's how you can do it. This button here is sort of a shortcut to update the brain's firmware. Again, same thing, you want to make sure the brain is plugged in directly and you're not going through the programming controller because that'll cause issues and try to update the programming controller rather than the brain. We don't want that to happen. So once you've done all those things, those are sort of first time things that are going to stay throughout the season. I do recommend you update your firmware as soon as you start. It's probably already up to date, but you can never be too safe. So those are all things you just do the first time you open. Once you close RobotC, it should keep those settings. It should keep all that stuff, and you should be good to go. But the first thing you're going to go into when you're writing a new program is motion sensor setup. It's going to open straight to one of these tabs. For me, it opened in Sensors tab, and you see there's a lot of stuff already here. So you want to make sure that we erase all this stuff. We are not using any of these things. It is slightly annoying that RobotC defaults to having lots of values here, but it only takes a second to get all those out. A little tip I recommend is once you've cleared out that motion sensor setup, you can save a file, an empty file with no motion sensors, and that can be a shortcut whenever you open to start a whole new project. Rather than starting a new file, you just open that file and then save it as whatever your new project is. So almost done here. Oops. All right. So anyways, this motion sensors setup tab is essentially telling your program how it's going to communicate with the brain, what's plugged into what ports. Please never forget to do this. I've done it myself. You write a program and then realize it's not working. A lot of the times you can accidentally use, there's some default variables for different motor ports and things like that, and it's easy to accidentally use those, but you want to be sure that you actually tell it what to do in the motion sensor setup, and you'll see that they pop up as selections as we go through this process. So if you recall from the last video, we have our bottom motor, which I'll show you that once we pull it up. We have our bottom motor plugged in to port 2, so I'm just going to name that bottom motor and set the type to a 3-wire motor. In port 7, we have our top motor, and I'm going to set that to a 3-wire motor. And you can see you also get some extra options out here on the side. And this is where we're going to talk about setting up a drivetrain. So let me switch back to my whiteboard here so I can show you what I mean when I tell it what's the left motor and what's the right motor. So again, this is the one I called bottom. This is the one I called top. So we think about this. If it has wheels, we'll pretend this way is the front. I guess that's a little confusing. We'll pretend this way is the front. So we want the wheels to spin this direction, right? When we push forward, we want the wheels to spin forward. RobotC has a little shortcut to set up your drivetrain. Rather than having to write, program, and map things to different buttons, you can simply tell it what's your right motor, what's your left motor. So if this is going to be the front, this bottom motor is our right motor, and this top motor is our left motor. So when you look at our motors, we have them. This is forward. Excuse my bad handwriting, but that's forward. So we want these motors to spin this direction. Something to think about is these motors are facing different directions. So if we're wanting them to spin so the wheel turns this way, one of them in software or in your however you plugged it in needs to be reversed at some point. That's totally up to you whether you reverse one of these plugs at some point, or if you tell it in software, you can reverse a motor. So generally, if everything's plugged in correctly, clockwise is going to be positive. So it's going to turn clockwise when you tell it to go forward. So for the bottom motor, it should be correct. But if my convention is correct, this top motor needs to be reversed. So we're going to reverse the top motor. And if we go back to the software, you will see that there's an option to check when it's reversed, and we can tell it what drive motor side it is. This works with more than one motor as well. If you happen to have 4 wheels on your robot, you can do that, and each one has its own motor. Now that's unlikely in Best Robotics since you're limited pretty heavily on motors, so you'll probably just have one set of motors. But I'm going to go and hit apply just to make sure I don't lose anything. And let's look at sensors. So a couple videos I talked about the different sensors. I showed you which ones to plug in the last video. In this particular case, our analog sensor is going to be a potentiometer. And it was plugged into port 1. So I'm going to set that to potentiometer, and I'm going to title it Potent 1, just a short phrase for it. It's an analog sensor. We have a digital sensor. We have our limit switch, and that is plugged into digital port 1. In the software, you tell that's a touch sensor, and I'm going to call it limit 1. A side note on naming things, there are some internal variables inside of RobotC. So it is possible that you could accidentally name it the same thing as an internal variable. So I always add a number to my motors, my names, whatever. Adding a number just makes sure that you don't have the exact same name as some internal variable. Because I have ran into problems. If you simply call something motor, a lot of times you're going to have issues there. I also forgot to add our servo. So we have servo, I'm going to call it servo 1, set it to a 3-wire servo. It is not a drive motor, so I'm not going to mess with any of those settings. But servo 1 is in port 3. So let's look at a basic program. The first thing I want to look at is programming the limit switch. So I mentioned earlier we're going to tell the limit switch to turn on a motor and turn it off when it's running. So the first thing, almost any time in a competition, if you want something to happen over and over again, you're going to need it to be inside a repeating loop. The easiest way to do this is using the repeat forever loop. So we're going to do that. The next thing we are going to use is an if-else statement. If you're not familiar with programming at all, an if statement basically checks a certain value and sees if it's what you told it to be. If it is, it does something. Else tacks on an extra piece to that where if it is not currently that value, if it's anything else, it's gonna do whatever you put in the else block. So this block sort of has 4 things to look at. So you have this top line, it's if select the value equals blank. So I'm going to select the value to be my limit switch. With limit switches, you get 2 different values. You get 0 and 1, true or false. So I'm going to say if it's 1, it's being pushed. I want the motor to turn. So the way that's going to look is we're going to use the set motor block right there. Make sure you set it to whichever motor. Actually, side note, you have to save your program and compile it before you actually can see those values. So make sure you do that, and then you'll actually see everything. So I'm going to do bottom over motor. I'll set it to max speed, which is 127. With your motors and servos in RobotC, you have values between -127 and +127. Those are sort of your max. If you put something over it, it'll just go the max. But I do recommend keeping that in mind when you're programming, and I'll show you why in a moment. I'm going to show you how to do some stuff with variables. Inside our else statement, so if that button's not being pressed, I want the motor to not spin. So I'm going to use the block stop motor, and I'm going to set it to bottom motor. So this program, it's repeating forever. We have an if statement. It's going to check if the sensor, the limit switch, is being touched. If it is being touched, it's going to set the motor to full speed. If it's not being touched, it's going to stop. So I'm going to download that to the robot. Let me get my limit switch. Here it is. go and start it. And it's working. So let me switch cameras. Okay, so you see I've got the limit switch here. We've got the motors. It's hard to tell that the motors are spinning with this video, but hopefully you can hear it through my mic. So when I push that, the motors are spinning, or the bottom motor is spinning. Very simple idea. This isn't necessarily a super useful use, but it does show you how to do that. Something I'm going to talk you through, and I'm not going to, one second. Something I'm going to talk you through, but I'm not going to actually show here is how to use a limit switch as a safety device. So let's say you have an arm, and your arm is going to get pushed back so far. If it goes too far, it's going to break. You can place a limit switch on your robot such that when your arm is about to go too far, it's going to trip that limit switch. And what that's going to look like is somewhere in your loop, you want it to check if that sensor is being touched, stop the motor. Something else that I want to say, just a quick tip, if all you have there is stop motor, it's going to push that switch stop and be immobile for the rest of the match. So you want it to, what you really want it to do is stop and take a second to move forward. So you might stop, set the motor to a speed that moves it forward for a very short amount of time, and then it'll get itself out of that loop, and you'll be good, and your robot's not going to get stuck. So that's a potential use for limit switches. I'm not going to show you the program because that's something you as a competitor need to figure out. So let's look at using the potentiometer. I'm going to delete all of that. If I can get it there. There we go. I'm going to delete all that and leave my repeat forever loop. Remember that if you're controlling your robot and it's not a sequence of events, you want it to be inside a loop because you want it to check again to see if whatever happens there. However, in this case, we are going to create a variable before the loop. So let's call the variable I'll call it potentiometer value. I'm going to let it set to 0 initially, but once we get inside the loop, we're going to sort of define what it's going to be. There's a little bit of math to this, so hopefully you can follow along, but essentially we're going to use this variable value block to set that value to the value of the potentiometer switch. And I'll show you in the debug panel what that value actually is. So let me go download that. Take the potentiometer. And you see down here, it shows potent value, and it shows that value. Well, it's not started. To start the program, you see it's reading that value. So all the way to the left, it's a 0. I move it up all the way to the right, it's 4095. So you can see that value changing as I turn it. I know you can't see me turning it, but hopefully you trust me. If not, maybe this video is not for you. So yeah, so here's the thing. Remember how I told you your values going to motors needs to be between negative 127 and positive 127? So we need to essentially scale, take a proportion of that value so that it is between negative 127 and positive 127. Now I'm going to start off with something a little simpler, and that is between 0 and 127, so that the motor will adjust its speed based on how much I've turned the value. So that's where we're going to use this variable expression block. I'm going to pop it right there. And we're going to set that potentiometer value to potentiometer value, but we're going to divide it. I'm not going to go over the math, but if you think about you've got 4,095 potential values and you want to reduce that to 127 potential values, it's pretty simple math, and it comes out to you want to divide by 32.2 roughly. Obviously it's rounded. So that's going to set our value to be between 0 and 127. Next, we can simply set the motor We'll do top motor for this one. We're going to set that to be potentiometer temp val. And so what it's going to do is check that variable to decide what the sensor is, or what the speed is. So we're going to download that. You can watch along the bottom here and see that value actually change. So it's turned up all the way, and we turn it down. So we're at 0. I'll switch over so you can see what's happening. Here you go. So we're at 0. I'm going to turn it. I'm just going to speed up. Hopefully you can hear it speeding up a little bit. As I turn it all the way up, it's going to hit max speed. So again, I'm not going to just give you the answer, but there is a way to potentially use that for setting the speed of your motors before a match starts, because you are allowed to touch your robot before the match starts and decide how fast your robot's going to move. So that's a potential use for a potentiometer. Another use I'm not going to show you is creating a sort of encoder to decide how much your arm is moving. You could potentially see, somehow rigging it so that your potentiometer spins along with your arm, and however much it spins is going to tell your cortex where that's at. Okay, so moving on, I've got one more sensor thing to show you, and that is another useful value, and that is mapping a servo to the potentiometer. So we have a little bit different math here. The servo, the values for the servo can be set between negative 127 and positive 127. So what I'm going to do is change the math a little bit here. So we're going to have double the values. So we need to essentially multiply this bottom part by 2, and it comes out to 16.1 is what we want to divide by. But before we divide by that, we want to set it so that rather than 0 to 494,095, we want it to be between negative 2,000, whatever that is, negative 2,000 and positive 2,000. So what we're going to do is add another expression before that. Let's see if I can get it in there. Come on. No wiggle down. There we go. So we're going to set potentiometer value to potentiometer value minus 2047. Oops, not 20,000. 2047. That's what happens. So what that's going to do is shift the values to be between negative 2047 and positive 2047, and then divide them so that it's between negative 127 and positive 127. And essentially that is going to map the position of our servo by using a set motor command and setting that servo to potentiometer value. I'm going to download that. Before I switch over and show you that moving, I'll let us look at that variable. So we're at negative, we're all the way left, negative 127, all the way right, positive 127. And my math wasn't perfect because I rounded, but as long as it's close, it's going to work. So I'll go and leave that started. Switch over to top down. We are going to move that left and right. And it's probably not easy to tell, but there we go. You should be able to see it there. So that essentially maps it. It's hard to do with one hand. I think I might have just had the screen pulled down that whole time. So let me show you the screen here, show you what that looks like. Again, the math here is subtracting 2047 to offset it to be in the middle. And then we are dividing it by 16.1 to make it between negative 127 and positive 127. And we're going to set the motor. I will cut that part out of the video, so y'all have to wait. Next up, I'm going to show you how to map your controller. So I'm going to go ahead and just move this whole block out of the way. We don't need a variable for this next part. This next part's really easy because we did that back-end work of telling the motors and sensor setup what our drive motors are. This next part is going to be really easy. But I do want to switch over here and use the whiteboard to show you what a couple words I'm about to say actually mean. So there's two main schemes, like I said, in the robot competition world for controlling robots. The first one is arcade. Essentially what you have with arcade, let's say you have a robot here. You've got wheels, say that's forward, and you've got two joysticks. Arcade maps one joystick to control the robot. So forward and back on that joystick is going to move the robot forward and back. Left and right on that joystick is going to move the robot, is going to turn the robot left or right, respectively. It's fairly straightforward. It's easy to use. The one built into RobotC maps it to a single joystick. Some people like to split it so that the left joystick controls forward and back and the right joystick turns your robot. Some people don't like that. I think that gives you a little more precision, but if you want to do that, you're going to have to figure out how to program that yourself, because I'm going to show you the easy way. I don't want to give away the answers. The second method is tank. So this tank, essentially, you think about having a tank robot. I'll pretend it's a tank robot. These are treads. Tank, if you think about like a zero-turn lawnmower, you push left to go forward or turn right, and you push right to turn right. Push both forward to go forward, and push both back to go back. So tank drive is that same idea, but with the joysticks. So it's going to map, actually let me do this. It's going to map that left wheel or left tread to that left stick. And then your right stick is going to be mapped to that right tread, like a power zero-turn mower, whatever you call them, where you're from. So that's the idea there. So hopefully that gives you an idea what the schemes actually are. And the way you program that is actually extremely simple. It's almost too easy. So remember that we always want to put things inside a repeat forever loop. And all you have to do is scroll down. You've got this remote control option. And we're going to select remote control, arcade control in there. You can change which channels it is. So channels 1 and 2 are the right joystick. This first channel is going to be your forward and back. And the second channel is going to be your left and right. This 10 is essentially sensitivity value. I usually don't bother with it. You can experiment with that yourself. So I'm going to download that and show you that working briefly. And we're almost done here. So I've got it mapped to this right joystick. I push forward. The robot's going to go forward. Back, it's going to go back. Left to right, it's going to turn. And I know it's difficult to see with this camera, but I'm sure you guys understand. You're all smart. All right, so I'm going to stop that. Tank control, it's essentially the same idea. You're just going to drag that tank control inside a repeat forever loop. Tell it which, did I switch? Did not switch, look at me, caught myself. Tank control is essentially the same idea. You can drag it from the same spot, put it inside a repeat loop, and tell it which joysticks to use. Another thing I want to add is arm control, because we have this servo in here, but we're not really controlling it. So what arm control is going to do is set that motor to move based on what buttons you're using. So I want to use the top right shoulder button, so that's 6U and 6D. So I'm going to set that 6U, 6D. I'm going to set that to 127 so it goes to the full range. And what that's going to do is let us control that servo the same way. This works with servos or motors. It works much better with motors. My actual recommendation for servos would be to have an if-else statement and say, if you push this button, move this direction rather than move. Because the way a servo works, you have to think about it a little bit differently. It's going to set the value rather than move sort of aimlessly. So you might have a button that sets it to a certain position and another button that sets it to another certain position. This works really well with arms, not arms, claws. You want your claw to open or close. So what I really recommend for servos is doing that. I'm just using the servo now. It doesn't really work great this way, but I want you to see how to do an arm control. So that's just going to change which way you do it. You can probably hear that moving. I'm not going to take time to show you. So that wraps up everything I wanted to talk about. I really hope that these 3 videos have been enough to get you started. If not, remember the resources I talked about in the first video. If you have some technical questions that you can't find anywhere on the internet, I recommend trying out the VEX Forum. It has a section for the VEX CDR platform where you can talk about what's going on there. There's also a section for RobotC there, and I linked to that in that previous video, as well as in the slideshow that I'm going to post on that video. I should have a link on this one as well. Thanks again to y'all for joining me. Hopefully you learned a lot. Hopefully you're ready to start your season. Best of luck to everyone. I hope you have a wonderful season. I know things are weird right now, but I'm sure you're all going to make it wonderful and have a wonderful time. So thanks for watching, and I hope to see you guys at your competitions.